All right, welcome back. So what we're going to do in this video here is talk a little bit about the different two-dimensional or different types of geometry that we work in within Rhino. So basically, we have to think about this geometry as being the basis for how we create models. Now, what's different from Rhino from many of the other types of software, and perhaps the most kind of frequently used one that we see is SketchUp, is that where SketchUp is a polygonal modeler that models in polygons, and I'll talk about what that means in a little bit, but what Rhino is a NURBS modeler, so non-uniform rational B-splines, which is a big way of saying basically that it's, if I'm putting it in very simple terms, it's mathematical based. So it describes geometry using math rather than actual trying to think about it in terms of kind of physical things. So, and that will be more clear as I talk about it in a little bit more. But basically what we use is mathematical equations to describe curves and to describe surfaces. Okay, so and generally a polygon will describe a surface or a mesh using 3 different points or 3 or 4 different points depending on planarity and stuff like that, but that will be more clear to you in the future. Suffice to say, let's get back to looking at the different types of geometry. So the first geometry is this point here. So you can see that right there is a point. We can create a point by coming into the command here and typing point. And you'll see that it pops up and we can click a point. And it's going to ask you for a location. So the location, a point, is going to be an X, Y, or Z location. So right now we are in a perspective view and we're on an X and Y. So we're just going to create, a point. It's going to be an X and Y, and we can see the location. The point is very humble, but as you get more advanced and you start to use plugins such as Grasshopper, points as references and also as building complex geometry to describe complex geometry via points is incredibly powerful. So don't let the humbleness of the point belie you. It's very powerful. So that's our point. It's described by X, Y, and Z coordinates. Okay. The next kind of step up is a line. And as we know from geometry, that a line is can be described by 2 points. So we have a start point and an end point. So if we go to create a line, we can type line. And right up here you can see. And it's going to ask you for a start of the line and again in the end of the line. But just a moment to talk a little bit about this interface is that when we start a command, you'll see that in this command line here, again, we have all these different options. Okay, we can have it start and grow from both sides. So if we click a point, it's going to be equal. So we could start from the midpoint and draw it out. Basically off a normal, that'll make more sense when we start talking about surfaces. Angled at a particular angle, we can have it draw vertical, which is very helpful when we're in this perspective viewport, because it's going to default to the construction plane, which generally is the world X and Y. I'll get to that in a little bit, but just suffice it to say that is helpful. 4 points, bisector, most of these two I haven't really used too often, but perpendicular and tangent and extension, those are all kind of helpful. But for the most part, we're just going to stick with a very simple one. So we're going to click here, and then it's going to ask us to select the end of the line. You'll notice that the command line changes. Okay, so there we go. Then we've clicked our line. So it's basically created from 2 different points, and we create a line. Now a polyline is a series of points. Again, I'm going to show you those points here in just a moment. So if I go over here to show the edit points, you'll see that the points show up. So this is what I clicked to create that line. Okay, now a polyline is basically, just think about it as a connected series of lines. But it also it has a very strong relationship to our next type of line, which is the curve. So curve is a smooth, sinuous, flowing line. Again, it's created from a set of points, and I'll turn those points on. And so I click, this is what I click to create this. These are called control points, okay? And then these are edit points. There's a slight difference between those two. But the interesting thing about a polyline versus a curve is that a polyline, these control points have what we call, a curve has what we call a degree, okay? And we can think about the degree in really, for now, in general terms, as kind of the smoothness of the transition from from these control points to another. So this, by default, when you're drawing a curve in Rhino, it defaults to a degree 3 curve, okay? You'll understand what that means later as you get more advanced. Don't worry about it. Just say that 3 is the smoothness. So the higher the number, the more smooth it is, okay? Whereas a polyline is also can be described as a curve, but its degree is 0, okay? So it's not smooth. There's 0 smoothness. That's why it has these facets to these different control points. So that's an important type of distinction. Now the next type of curve, this is a control point curve, okay? And I did that by clicking this, right? We can get the start, and you can see here that the start of the curve up in the degree is 3. That's the default, right? Okay, but there's another way we can create curves, because sometimes you're creating this curve and you're like, well, I don't know where this point should end. So you can create an interpolated curve, which would be this curve, interpolated points, okay? And what that allows us to do is to click, and wherever it's going to draw the curve through the points. So that can be handy at times. Usually it's not as smooth in these transition as a control point curve, but it's a pretty handy thing to deal with. And you can see that it has its control points, okay, and it also has its edit points, so it's the points that we created it with. All right, then the next stage is shapes that we can create. So we have circles, and we have rectangles, and polygons, and n-gons, and that means that depends on n meaning any number of sides. So right now this happens to be 5 sides, but we could make it 6, 8, whatever. And those, again, we create these shapes by either typing. So we could type circle, for instance, and we can create a circle by clicking, and then again it gives us some options. We could create it by the diameter, we could create it by the radius, circumference or area. Those are all really handy, and so we just click and drag out, and then we get our curve or our circle. Same thing with rectangles. So we type rectangle, and we have a couple of different ways. The default is to go from corner to corner, but we can also do a 3-point, which means we could click the width and height. That can be really handy at different times. So there's different ways that we can create those. All right, so the next classification of geometry, so those are all kind of our curve sets. Now, each of those don't really describe any sort of surface or 3D model like we would think about in the traditional sense, where it would start to represent a surface. So that's our first step, is the surface. As right now you can see that it's thin, it has no thickness. That's a basic surface. I created that by clicking over here a surface from 3 or 4 corner points, and just clicked some points and we've created a surface. Okay, so that surface, it also has control points and that we can look at. So I clicked on this control point over here, and it has control points, so it's described very much like a curve, and we can create surfaces from curves, and we'll get into that when we get into the geometry. But we can also select these control points and we can modify them, and we can change how this this surface starts to become. So right there I just created a hyperparaboloid by editing it. Same thing, we can do similar things with editing these curves, and we'll get into that a little bit. But I wanted to show you that a surface doesn't have to be totally flat. It doesn't have to be completely planar. It can have curve to it. And that's the great thing about NURBS surfaces, is that it's very curvilinear. It doesn't have to be planar all the time. When we talk about meshes and polygons, then planar things being flat becomes critical. All right, so the next type of geometry that we have is a solid. Okay, so there's a couple of different ways that we can think about a solid. So the solid really is a series of surfaces that are joined together to be closed so that it encloses a volume. So a box, because it is totally enclosed, creates a volume, so we could call it a solid. All right, now I can explode. So I'm going to select this, and I'm just going to go over here, and I'm going to break it apart into its basic surfaces. Okay, so now we can see that it's composed of different surfaces, just like this surface, but we've joined them together. So when you have a series of these surfaces joined together, I'm going to join, so I've selected these and I want these to be joined, so I'm going to come over here. I can click on join, or I can type join. And what you're going to see is that although they're collected together, you'll notice that this is a polysurface. So we've created a polysurface. A polysurface is a collection of joined surfaces, multiple surfaces that are joined together. That's called a polysurface. If we put them all together so that it makes all a solid, if it's all joined into a solid, it becomes a solid. Okay, now a solid is totally enclosed, and we can do special functions with it, but you have to imagine that because it's made up of many surfaces, it is also called a polysurface. So the only difference between a solid and a polysurface is it's just a polysurface that is totally enclosed to hold a volume. So that might be a little bit confusing right at the moment, but maybe watch this video a couple of times, and that'll keep you give you an idea about what are the things that we're going to be building geometry with. Okay, so the other thing that I wanted to talk about before we leave here is three-dimensional space. You'll see that I'm in the perspective viewport. Okay, and that perspective viewport, I'm navigating around in three-dimensional space. And then I have X, Y, and Z over here that shows me the Z being the elevation, X and Y. And you'll notice also that we have this green and red. That is an axis to help us navigate in space, because if we didn't have these couple of things, we could get very kind of lost. At the convergence of these two lines here is the 0, 0 point. That's the origin. Okay, so that's the 0, 0 point. And when we get into understanding construction planes and things like that, then that understanding of X, Y, and Z space and the origin becomes important. So I just want you to kind of plant that in your mind for later, that we're in three-dimensional space. We have an X and a Y and a Z, and that becomes important in the next few videos. Okay, so hopefully that gives you some ideas about basic geometry, the different types of geometry that we're going to be using, and those become fundamental for as a basis for us to model our projects. Okay, talk to you soon.